for your computers. Okay, so let me share this one here. And let's do a brief introduction of what we're going to be doing, okay? So we are going to start during this first, I think during this first two additional classes, we are going to be talking about how to use MATLAB. And what we are going to be doing is we are going to be presenting examples, okay? So we are going to do economic examples and we're going to do financial examples. Now, what I will do is I will try to do a summary of the models so you can have an idea what the models are talking about, how the models work, and then how we can implement them easily using MATLAB. Okay. Well, last class, what you were doing is basically how to create variables on MATLAB, right? So MATLAB works as any other program, Python or any other program, R, even more complex languages like C or D. They always define variables, and what you need to do is you need to input a value for these ones here. Okay. What is interesting about MATLAB, guys, and why MATLAB is very useful for economics is that the variables are normally inputted as vectors. Okay, so vectors normally can be a row vector, looks like that, so you have numbers, or it can be a column vector, so it looks something like this. No, and vectors, of course, if you join vectors, we are going to have a matrix representation of what we want to do. So in a matrix, of course, guys, is going to be something like that. It has columns. So this is going to be called n times m. Always the first one refers to rows, and the second one refers to columns. In MATLAB, guys, and this is different from R, this position here, okay, so this position here is called position 1, 1. Okay, so this one here is position 1, 2, etc. And this position here is going to be row 2, column 1, etc., etc., etc. Okay, so always rows and columns. This is the way it works. And I don't know if in the previous class we also discussed something about arrays. Okay, so what is an array? An array is basically a three-dimensional matrix. It goes, so we are going to have one face, but we're going to have multiple faces. Okay, so these ones are the rows. We're going to have columns here, and we're going to have faces here. Okay, so this is the way we're going to be start working with. Now, MATLAB uses this notation here. Okay, so if you want to find a specific column or position, you are going to tell MATLAB, this is the way, this is what I want to find. Okay, and what is the notation here? The notation here is always going to be rows for arrays, rows, columns, and faces. Okay, we are going to work with this today. So hopefully you have reviewed your YouTube video last time, so you can follow me very quickly. Okay, let's do an introductory example. Okay, guys, you create this in MATLAB. So do you have MATLAB, right? Can you open your MATLAB, please? I will do this in a minute. So let's create a matrix, okay? Let's call this matrix A, something very simple. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Just let's create this matrix A. And let's create another matrix B, for example. Can be, let's say, 9, 10, 11, 12, 13, 14. Just any numbers, okay? Let's create this matrix A and B, and then we're going to try to do a lot of things here. Okay, so I want you to find A1. I want to be this part here. I want A2 to be only Okay. So let's say 3 minutes, guys. What I will do is when I give you some exercises, guys, I post the video. Please, when we start, remind me to start again the recording, okay? So let's say we have 5 minutes to do this stuff. I will pause the recording.
Sorry, Professor.
Yes,
So we're trying to do this in MATLAB, correct?
yes,
Okay.
exactly. So we create A in MATLAB. We just need to type A and B,
Yes.
okay? And then we do A1, A2, etc.
Yes. Okay. Thank you.
Pleasure. Let me define my A variable. Let me define my B variable. 9, 12. Guys, if you have questions, please ask me, okay? At this point, we are learning, so you just let me know. And just try to do it as quickly as you can. Yeah, 2 more minutes, guys. Okay, so let's try to do this, okay? What I want to do, first of all, let me record this one here. So let's try to do A1. So A1 is what, guys? It's simply, A1 is simply, where's my mouse? Here. Is this part here, right? So we want the 4 first elements of the matrix. We want 1, 2, 4, and 5, correct? So how do we define A1? What can I say, guys?
You can say A1 equals A parentheses bracket 1, 2.
Yeah, 1, 2. Yes. So I'm doing this as a matrix notation, correct?
Yes. And then again 1, 2 and close parentheses.
What do you think, guys? So remember, notation is these are my rows and these are my columns. Okay, so what we are saying is basically take from matrix A rows 1 and 2 and columns 1 and 2. Make sense? Here we go. Another notation that is really important, guys, let's call this A11, is using sequences. Do you remember sequences, guys? So what I can do is this one here. Well, in this case, do you remember what this is doing here? 1 to 2. So let me copy this one here and just chat a little about sequences. For example, guys, I have x equals 1 to 1. 1 to 10. What this is doing? What this sequencing is going to be doing?
Is it getting all the numbers
Yes.
between 1 and 10?
1 to 10, right? If I use only 2 arguments here, this is going to go 1 by 1. So normally what I can do is I can do this. It's exactly the same. Got it? But sometimes we want to increase in 2s or in 1.5 or whatever you can imagine. So the sequence, so that the increment goes in the second position. I will do this just for notation. So what I'm saying here, MATLAB, is, okay, do a sequence from 1, increasing by 1, and stop at 10. Got it? So that's what I'm telling. And that's what you create. I'm sorry. This is what you are creating. So when I was doing this stuff here, guys, what I was telling is, okay, take from A 1 to 2. So this is 1 and 2, and 1 and 2. So we get exactly the same using sequences. Okay. So this notation is a matrix notation, is good. You can also do this stuff with a sequence. Of course, sequence, guys, works if and only if you have consecutive numbers, right? Or if you want to take the first, the third, the fifth, etc. So you can change this stuff. Make sense to everyone?
Yep.
Okay, so now let's go and select only the third column of A. So A2 is the third column of A. So this is going to be A2 equals what? A, I want all the rows and I want the third column. Make sense to everyone?
Yep.
Perfect. So let's do the other one. I want the second and the third column. This is my A3. I want from here my second and third rows, all columns, right? This is what I wanted. Yes, it's the second row, second and third row, all columns. So this is the way, guys, you tell MATLAB everything. So this is what it's telling us. MATLAB is, okay, take from 2 to 3. In this case, it's 2 and 3. All single columns, all columns. So this is also an important notation that we need to remember. Okay, so let's go to the other one. I want the transpose. Transpose, guys, is something that we're going to be using all the time in economics, okay? So this is A4. And how do we do the transpose, guys?
A apostrophe.
Exactly, just A apostrophe. So what it does is the following. So let me put this A again. So what is a transpose doing, guys? It's simply doing the rows become columns. 147, 258, 258, 3, and 369. Okay, that's a transpose. We're going to use that a lot. So, but it's very simple to do. Now, the other one, sometimes we also need this one when we do data manipulation. So what I want is I want to move column 3, column 2, and column 1. So what I want to do is to reverse the order. This is, where is my mouse? Give me 1 second. So what I want is to move this column here to be the first one, this will stay the second, and this one to be the third column. Do you remember how do you do that? There are a couple of things that you can do this. So let's call this A5. Someone.
If you do colon, comma, and then using matrix notation.
Yeah,
3,
all
2,
the
1.
all the how do you call it? All the rows, right? Then
Yeah.
3, 2, 1
3, 2, 1. Yep.
should work, right? Now, if I want not to use the matrix notation, I want to use the sequence notation. So how do you do that? So I want to use a sequence notation. So what I want, guys, is to go then 3, 2, and 1, correct? That should be what appears here. How do I tell MATLAB go from 3 to 1, decreasing by 1?
3:1.
Yeah, 3. Here we have an issue because what is going to be 3:1? That remember that default increase is 1, not -1. Do you agree? So you need to be
Oh,
explicit here to write this one here. So we tell them 3 minus 1, comma 1. So it's going to be 3, 2, and 1. Make sense? Now, this one, these 3 here, you know, if we change that, the matrix, the dimensions of the matrix, we need to be careful when we program because this number is not going to change. So what we try to do is something that is more dynamic. How do I make this automatic? So if I change the matrix A to another matrix, this still works. So how can I do that? Let's call this A52. So I want this to be automatic, guys. These 3 to change according to the dimensions of the new matrix. 3 represents what? Number of columns or number of rows?
Columns.
Columns. Okay, so how can I tell MATLAB, tell me number of columns? I want a command that tells me how many columns my matrix A has. Do you remember that? Okay, so let me copy this one here. There is a command, guys, that is called size. Oops, sorry, small caps. If I put size of A, what do I get? What is this 3 by 3? What is this 3 and what is this 3?
3 rows and 3 columns.
Exactly. The first one is rows and the second one is columns. Okay, so what if I want to just focus on the rows? I want to know how many rows do I have. So it's going to be size of A, comma 1. Yeah. Do you agree?
Mhm.
When you write 1 here, it provides you the number of rows. Well, in this case, my rows and columns are the same. And when you write here 2, you get the number of columns. There is another command, guys, that is called length. Do you remember what length does? Length gives you the highest dimension between the rows and the columns. In this case, rows and columns are the same, so it's providing any of them. But length, if you have, for example, a 10 times 1 or 10 times 2 matrix, length is going to give you 10. Make sense? So length gives you the largest dimension of a matrix. Now, if you want to know how many observations do you have in your matrix, how do you do that? Of course, my matrix A is we have 9 elements. Do you agree? How can I compute the number of elements, the number of observations, total number of observations that I have in my matrix? So,
Product.
yeah, product of what?
Size.
Yes, product of size of A. Because remember, what it will do first is what is in parentheses. Size of A is going to give me 3,3. The prod multiplies the elements of a matrix or a vector. So it's going to multiply 3 times 3, and then I obtain my 9. Got it? So this is one thing that you need to remember, because normally when we work with data sets, we are going to be always looking for, okay, give me the number of observations, number of individuals, okay, give me the number of total observations, etc. Give me the number of years in the sample, etc. Make sense? So you need to be proficient on the use of this part here. It's very simple. Make sense, guys? Okay, so now I can do this one here. So if I want to have this, what I put here in order to make this more automatic? How do I capture the number of columns? Should be size of A, what? Columns is equal to 2, right? Then this should work. Make sense? And so what is beautiful about this one here, guys, is let's do A52 for B. Remember, we have a matrix B. So what I want is let me copy this one here. And let me delete this one for 1 second. Okay, so just remember what is B. B is this one here. So imagine, guys, that you want these two here. Okay? So how do we do that? I call whatever, this is going to be B. Well, now I want the number of rows. I want rows number 2, etc. So I should change this to size of B 1. Well, it's not a good example. Well, yeah, perhaps yes. You know, guys, what I want from here is this one to appear the last, this to stay, and this one here to stay up, to become the first row. How do you do that? Should it work or not? So what I'm doing is I'm flipping this number here this row here is going to be the first row, this stays the second row, and this is becoming now my third row. Make sense to you? Should it work or
Yep.
not?
I think it should.
So what I'm saying is size of B 1. So I'm saying number of rows of B, number of rows is 3, decrease by 1 up to 1. So it's going to be 3, 2, and 1. So it's going to put first the third row, all columns, the second row, all columns, and the first row, all columns. Exactly what we wanted to do, right? Makes sense? So, and this is the way, guys, in which we're going to start programming. We want the variables, the programs to be as flexible as possible because the data is going to be changing. So I can have 2 columns, or I can have 4 columns, I can have 10 columns. It doesn't matter. Got it? So what we try to do is we try to make our code in such a way that it's going to be very flexible to accept a new data. Make sense to everyone? Okay, so I've done this basically. A6, what we're changing is the rows. So let me put A again. And A6 is going to be equal to what? I want from A, I want all the rows, right? Size of A, comma 1. Sorry. -1 to 1. And all columns. Make sense? Questions? Questions, guys? So let me type again A2, A52. You see these guys, what we have done is we have flipped the number of what we have done here. 369, what is this one? All rows, 7, 8, 9. So what we have done here, wait a second. What is my A, first of all? Oh yeah, this is my A, and A52 equals what?
You inversed the columns.
Yes, so the columns have moved left to right, right?
Yeah.
There is another way to do this stuff. You know, the people sometimes use this one here. It's simply a command, flip left to right of A. You know, you see, it does exactly the same. This is more generic, but if you want to learn a little more MATLAB commands, it's simply flip left to right. Of course, there is also another command that is called 6.1, that is flip up and down. Oh, that simply flips the rows. Make sense? questions, so we can do more and more stuff here. I just want to be sure that you understand this part here, guys. That is crucial. So now what I want is that we continue with this one here. Just create a C that is going to be A and B. Okay, so just put these two matrices together. I want D to simply replace the last column. So it's going to be exactly like C, but last column of C should be equal to, let's say, 9, 9, and 9. Okay? I want A, B, C, D, E that simply deletes fourth column of C. And F replaces position 2, 3 by 999. Two minutes to do this, guys.
Sorry, question.
Yes, please go
So
ahead.
for D, you want
D.
C to be the last
Oh, no,
row
no.
should,
Yeah, so what I mean is, you see this column here, this one here? When you join A and B, this is the last column of C, right? I want to replace these numbers by 9999. So instead of
got
12,
it.
it's 9, 9, and 9.
Great, okay.
Okay.
Hi, Professor.
Yes,
For F, we're
yes.
replacing a 2x3.
Oh, no, no, no. Replace position.
Oh, okay.
This is position. So basically, I don't know, it's going to be 2, 2, 3, this one, right? Replace this one here by 9999.
Okay. Okay, thank you.
Okay. 1 more minute, guys.
Sorry, Professor, can you show
Yes,
me again?
yes. This position, you see, position 2, 3 is this one, right? Second row,
I
third
don't think
column.
I'm seeing the right
Oh,
thing.
this one.
Sorry.
Do you see this one? My mouse.
I see the whiteboard.
With my okay. Do you see this one? My mouse moving.
It's not moving
Oh,
for me.
really? Okay. So
Yeah,
let
I
me.
can't see it either.
You cannot,
I can't see it moving.
or you can see moving.
No, I
Uh,
can't. Sorry.
you can't. Okay. So let me do something. Let me stop this one. Stop sharing and share this again. Okay. So now do you see my mouse? Let me move this somewhere here.
Oh, I see you circled
Yes, the
6.
6. Exactly.
Yeah,
So this
okay.
is position 2, 3, right?
Yes.
This is this one here. Just
Yeah.
replace that one by 999.
Okay.
Okay.
Thank you.
Pleasure. 2 minutes and then no, 1 minute and we start doing stuff. Okay. So let's continue recording. And so what we do normally, guys, when we have a lot of data, we try to join matrices, etc., etc., etc. Okay. So what I will do is I call this C, and C is going to be simply matrix. It's going to be a matrix. Remember the brackets. Give me not tells MATLAB A. MATLAB consider this as a matrix, A and B. And as soon as A is a 3x3 and B is a 3x2, so the number of rows match, so the join is perfect. Make sense? So this is the way you
Professor.
join matrices. Sorry?
Are we
Sorry.
supposed to be seeing MATLAB
MATLAB.
or yeah,
No.
so we just see your whiteboard.
Why is that? Give me 1 second. So I need to share entire screen. Okay, now what do you see, guys? MATLAB?
MATLAB.
Okay.
Yeah.
Okay, so give me 1 second. I want to change to Paint. Now, do you see Paint?
Yes.
Okay, so now it's working. I don't know what's going on. Okay, so what I told you guys is that as soon as A is a 3 times 3 and B is a 3 times 2, so the number of rows equal the number of rows in each matrix, so we can join them together, right? So it's an easy matrix manipulation. I will show you later other type of manipulations with unequal dimensions. But it makes sense to you? So this is my C. Now, what I'm telling to you is build D, and the only thing that I want is replace the last column by 9999. Okay, so let's do 2 steps. So let's do D equals C, right?
Yeah.
Correct? So I've done nothing. So now what I want is I want to replace from D everything, comma, 1, 2, 3, 4, 5, right? I want this to be equal to what?
999.
Yeah, it can be 9. It's going to be a column, right? So I need to write in this way, correct,
Yes.
guys?
Yeah.
9 semicolon, 9 semicolon, semicolon. Otherwise, you can do 999 and apostrophe. You transpose that. Make sense, guys? So this is the way in which you simply replace values, a complete column from another column. Now, there is one MATLAB command also, guys, that allows you, instead of doing 9999, so you can do this using another command. Remember what was that? So let me call D1 again. D1 is C. And what I will do is this one here. Instead of writing 999, imagine, I told you, imagine that it has 1,000 columns or 1,000 rows. So you're not going to be typing 99999, right? How do you create a vector of nines? Do you remember there was something that we call repmat? Oh, sorry, no, it's not caps. Do you remember this command? This command is also very useful. Repmat implies that you are going to repeat something. Okay, in this case, a number. How many rows are gonna repeat? 3. How many columns? 1. Okay, so this is the notation of repmat, guys. Repmat is what you want to repeat. This can be a vector, a matrix, an array, whatever you want. How many rows? 3. How many columns? 1. Make sense? So this is the way in which you replicate. So let me copy all this stuff. And just let's do repmat 9, 3, 1. You see, this is what it's doing. Make sense?
So, yeah, can you just say again what each of the values are? The first number
Yes,
is
definitely. The first one here is the value, or it can be a vector. Let's talk about vectors and matrices that you want to repeat. Okay. The second argument is going to be the number of rows, how many rows you want to repeat, and how many columns you want to use. So let's do another example. So for example, I want to repeat this a 3 by 3. You see that? Or I want to do this a 5 by 1, whatever you can imagine. So what do you want to repeat? How many rows? How many columns? We're going to use this later for some financial examples. Make sense, guys? Okay, so I can do also, instead of doing this stuff, I can do, this is also feasible. Repeat 9 3 times, 1, and put these values in D. We use all the rows, position 5. Here we go. Okay, let's go to the next one. Oh, I want to delete the 4th column of C. So let's do E. Let's do this in pieces. E equals C. And I want to disappear the 4th column of E. How do I do that? I need to first identify what do I want to delete? 4th column. And how do I want this to be? Empty. So for MATLAB, when you do bracket, bracket, this implies empty. Got it? Makes sense to you? So I want E is already equal to C. So from E, I want to delete the 4th column completely. And so this is the way I do it. Oh, I forgot 1 comma. Here we go. Makes sense. Questions? Okay, let's do the last one. Well, replacement. F, I need to create F that is going to be equal to C, and I simply want to replace this position 2, 3 by 9999. So let's create F equals C. And then I want F position 2, 3. And I want this to be equal to 999. Here we go. So this type of notation, guys, is when you have data sets and you have huge data sets and you want to clean, for example, the ones that are infinite or the ones that are empties, you know, this is the way you're going to do that. I will show you more that there is find commands, etc., but this is going to allow you to do this stuff. Make sense, guys?
Yeah.
Yep.
Okay, perfect. So now the next thing that we need to know is something that is called array mathematics. Okay, let me very quickly, let's do this let me, give me 1 second, please. So let's do array mathematics. It's very simple. And then we're going to start running. Okay, guys. So array mathematics is the following. So imagine, let's create again A. Okay, let's do something simple. 1, 2, 3, 4. And let's create B equals 10, 11, 12, 13. Okay, so all matrices. Now what I want is, remember guys, array mathematics is A plus B. So what is the rule here? They must be the same dimension. If this is an n times m, this must be an n times m. Got it? Now, there is something that is called, okay, so if we want to multiply them, so if I want to do A times B, so the rule is if this is n times m, this needs to be m times whatever, j. Got it? So what is important when you multiply, guys, is the number of columns of the first one equals the number of rows of the second one. So this is the product. Yeah, this is a very simple matrix manipulation here. Now, there is one thing that is really crucial is element by element notation. So for example, this has a very particular way of multiplying, right? It's going to be this times this plus this times this, correct? And that the second one is going to be this times this times and this times this. And then you multiply. There is another one that is called element by element multiplication. So for example, I want to do dot star B. So what it will do is it will multiply 1 times 10. So basically this is going to do the following. It's going to be 1 times 10, 2 times 11, 3 times 12, and 4 times 13. So this is the element by element multiplication. You also have the element by element power that we use a lot. So what is the element by element power? Simply is going to be 1 to the power 10, 2 to the power 11, 3 to the power 12, and 4 to the power 13. Matrix multiplication, guys, is more complex than that, okay? So matrix multiplication is going to be 1 times 10, 1 times 10, plus 2 times 12. The next one is going to be 1 times 11, plus 2 times 13. The other one is going to be 3 times 10, plus 4 times 12. And the last one is going to be 3 times 11, plus 4 times 13. Okay, so I'm noting these two because they are different. Product, the simple matrix multiplication, is not the same as an element by element multiplication. Do you agree? Element by element, you take 1 by 1, and then you simply do them. You simply multiply 1 by 1. The power is something that we always use. And the other one that is scalar multiplication, for example. So if I have A, times a scalar is a number. So what it does is simply, for example, assume that this is equal to 9. Okay, if I do A times 9, this is going to be 1 times 9, 2 times 9, 3 times 9, and 4 times 9. Okay, I think that with these ones here, okay, we are okay. Can we please compute these numbers? I want to see the values here in using MATLAB. Let's say 3 minutes. So let's use A and B. I'm pausing. Please remind me to unpause later. Okay. Let me create my matrices in MATLAB. One minute, guys, and then we do it. Please do it. Okay. The only way you learn this programming is just by doing. If you have questions, please ask me. Okay. Let's continue, guys. I record again. So my first question was simply A plus B. The question for you guys is, can we do A plus B? Let's call this C. Is A plus B going to work?
Yes.
Yes,
Mhm.
because the dimensions are exactly the same, right? So C is going to be simply this one here. You simply, the sum is 1 by 1. It's 1 plus 10, etc., etc., etc. Now, can I do the matrix multiplication? Can I do
Yes.
this? Yes, because
Yes.
the number of rows, sorry, the number of columns of A equals the number of rows of B. Okay, so this works. Now, is this equal to element by element multiplication?
Yes.
No.
Yes or no?
No.
No. No. That's why I was writing this for you guys. You see? Take a look. When you do element by element multiplication, indeed, element by element implies that the first row and column, 1 multiplies by 10, 2 by 11, etc. This is the element by element multiplication. The matrix multiplication is more complex. So it is like this. Got it? So element by element multiplication is not equal to the simple matrix multiplication. Make sense to you guys? And then we can see this in here. Completely different numbers. Now, the other one, F was equal to a power, I think, right? A element by element power of B. One to the power of whatever is always 1, while the other ones are big numbers. And then I simply multiply by a scalar. So this is Fg is going to be equal to A times, I think I put 9. You know what it does? It simply does element by element multiplication, scalar multiplication. This one here is called scalar multiplication.
Professor,
Yes, go ahead.
what if we have our data set, it's a huge data set,
Yes.
and matrices are
Mhm.
not the same size or like
Well,
number of columns is different.
Yeah. Well, there are a couple of things. You know, if you do, for example, econometrics and you want to do an econometric analysis, you must have the exact number of the matrix must be conformable. Conformable means that they need to satisfy this rule.
Yes.
Okay, so if you have, normally that's the only way you can do this in time series or regular econometrics. When you do panel analysis, you can have unbalanced matrices. So what you do when you have unbalanced matrices, I will show you later when we do panel analysis. We simply increase or we simply include empty values. Okay?
Okay.
It's
Mhm.
going to be easy. We're going to see that, but I need more knowledge, more language for you first.
Okay, thanks.
Okay. Okay, questions, guys. Okay, so now let's do something simple that has a very beautiful application in economics. So let's do the following, guys. Let's do I think we did this in the video. I don't know. Can we create x? X I want to be, it starts at -3 to 3, increasing by let's say by 0.5. Okay, so create x that is going to be a vector that's going to be -3, -2.5, etc., up to 3. Okay, so you have a vector here. Then what I want is you to create y. Y is going to be a vector, and let's assume that it's going to be a vector. It's going to be a 4 minus 3x. So and create y that is going to be an equation, a linear equation equals to 4 minus 3x. No, this is minus. Okay. And then let's talk a little about the equation of the line. First, create this one here, and then we talk a little about the generic form of an equation of a line. Okay, I'm here. So let's create this matrix, okay? This vector. So I want x to be -3 by 0.5, right? Up to 3. Make sense to you guys?
Yeah.
So what do we have? Oh, why I have this one here? What's going on here? Is this one here? It's increasing because I started with a negative number. Okay, so it's going to be 3 minus 2.5 minus 2, etc. So I have 13 numbers here. Just give me 1 second, guys. 1 second. Okay, guys. So let's continue. Okay, so what I will do is to create a linear equation or whatever is very simple, right? MATLAB works like a program, like a normal Excel, or of course it's much more powerful than that. But what I am saying is create an equation is very simple. What we just need to know is the parameters. Later I will show you how to estimate parameters. But in this simple example, I'm saying is 4 minus 3x, okay? So it's going to be equal to 4 minus 3 times x. Oh, it's plus, it's not plus, minus. So this equation here, I simply click this one here, and I have my y. Okay, so my y is related to x in this way. So now let's talk a little about the equation of the line. You should be familiar with the equation of the line, right, guys? I will do a very quick review because this is important for economics. Make sense to you? Do you understand what we have done in MATLAB?
Yes.
Okay, so
Yeah.
now let's go to a generic way of describing an equation. So I will have in general, guys, this is the normal notation of a line. How do we call this one here? This is what is called my y-intercept. How do we call this v? Do you remember?
Your slope.
The slope. Okay, so basically the slope, if it's positive, implies that the line is like that. If my slope is negative, implies that the line is like that. Got it? Now let's take a look to one example. For example, if I tell you, okay, let's do this 4 minus 3x. How do you see this one here versus y equals 4 minus 0.5x? Okay, so let's do the first one here. I will just do gross, okay? So this is my y, this is my x. So 4 implies that this is this value here. When x is 0, y is 4. So this is my first point. And then I can see what happens when x is, for example, let's do 3. No, let's do 1. What happens when x is 1? So it's going to be, y is going to be 1, correct, guys?
Yes.
Okay, so I have 2 points. I can make my line. Hopefully my line goes to you. Great. So this is my first line. Now, what about the second line? So let's use a different color. Let's use a different color. So I have, when x is 0, this one is also crosses at 4. But now let's assume what happens when x is 2. Let's do 2 here. When x is 2, this is going to be 1. This is going to have a value of 3, correct, guys?
Yes.
So this point, I have 2 points. I can join these 2 points. And this is this. Do you see? Now, what is crucial, of course, I'm using negative slope. So the slope is that the line is like that. The slope, this number here, simply tells you how steep your function is, your line is. The larger this number, the steeper the value, the steeper the line. Make sense to you? Minus 3, for example, is like that, the black line. Minus 0.5, the line is flatter. Make sense to you guys?
Yes.
Okay, so why this is useful in economics? Let me save this one here. So let me open. Have you heard about demand functions in economics? Have you heard about the demand and the supply?
Yes.
Yeah.
Yes. Okay, so let's talk I will focus only on the demand side, okay? Demand equation. Now, a demand equation, guys, has a very particular law. There is the law of demand. What is this law of demand? The law of demand tells you simply, guys, that your elasticity, and this is weird. In economics, we use Q here and P here. Okay? So the law of demand tells you the following, guys, that the relationship between prices and quantities are negative. So what is the idea of that? That if the price starts increasing, what happens with the quantities, guys? The quantities start decreasing. Okay, so this is a famous law of demand that simply implies that the demand function, so this is my demand function, linear, has a negative slope. Make sense? Make sense, guys?
Yes.
Okay, so a demand function has very particular, has a lot of things that are going to be useful for later. We have the slope, so at this point, let's focus just on the slope. Okay, I want you to build demand functions with different slope. So what is interesting with the demand function with the slopes? Okay, so let's take a look to analysis of the demand functions. Functions and the slope. What is the relationship with this? So take a look to what happens. I will have two products. I will have one product that looks like that, and I will have another product that is more like that. Okay? So now let's start at a given price for both of them. I see P0. For this P0, I get this Q0. Okay, so this is Q and this is P. P and Q. So I will do the same price. So we start at this P. This is going to be the quantity that is going to be demanded. Agree with me? So now what I will do is I will do a promotion and I will decrease my price from P0 to P1. Okay, so P0 decreases to P1. So what happens according to this demand? My quantity is going to increase to Q1, right? This is the law of demand. And let's do the same exercise here. So I decrease my P1 to P0 to P1, the same decrease on prices. But take a look to what happens with Q1. Of course, Q also increases, but which one has a larger impact? Which price decrease has a largest impact on quantities? Which one, guys? This size
The one on the
here,
right.
yeah, this size here is much larger than this size here. Agree with me?
Yeah.
Okay, so this one here is called an inelastic demand function, and this one here is called elastic demand function. Okay, I will stop here because we can also have inelastic and elastic in the same line. But do you understand the logic? So if you have a product that is inelastic, basically you're going to have the slope is going to be very strong. Inelastic means, guys, that basically no substitutes. No substitutes or very little substitutes. Okay, for example, oil. Oil is always an example of non-substitutes. So, well, now it's coming electric cars, but even though we have electric cars, still machinery and factories work on oil. Do you agree? So you cannot change oil. Airlines, for example, even though the price of oil increases by a lot, they cannot simply say, okay, I will not use oil. They need to continue using oil. The only problem it's going to have with airlines is that the cost structure is going to start increasing. Make sense? So profits are going to start decreasing and eventually they're going to start losing money. Or at the same time, they need to start charging more the clients, more the passengers. Make sense to everyone? So what I want from you is I want you to be able to create this type of functions. What I will do is I will give you three points, and I want you to build the demand functions. Okay? So if you understand this one here, I want you to do the following. So let's assume that we're going to have three demand functions. Okay, so demand one. So you're going to model this in MATLAB. Demand one, my A and B. Okay, so let's assume that my y-intercept for demand one is 10, and the slope is minus 0.5. Let's do demand two. Let's assume that this is 15 and minus 1. And let's assume demand three is basically 30 and minus 2.5. Okay, and what I want you to is use the generic formula P equals A plus B Q quantities. And let's start modeling Q. Okay, so Q is going to be from 2. I will explain in a minute. Let's do this from 0 to 20 for demand 1. 0 to 15 for demand 2. And 0 to 12. So this is the range of values. Range of values of Q. Okay? So basically, I'm giving you the slope. I'm giving you A and Q. Sorry, where's my mouse? Oh, here we go. I'm giving you the y-intercept and the slope for three demand functions. So all the three demand functions have this form for a mathematical formula. And I want you to create Q is going to be from 0 to 20, 0 to 15, and 0 to 12. Once you have created these functions here, so we can call perhaps, I want this to be called Q1, this to be called Q2, and this to be called Q3. And with this information here, guys, with these are going to be sequences of data. Just use the formula for each of them and create a demand function 1, demand function 2, demand function 3. Just create the vectors. I want you to create the vectors, and we are going to graph them in a minute. Questions? Okay.
Yeah, do you
Yes.
want the Q values to be increments of one?
1. Yeah, let's do increments of 1.
Okay.
Okay. Well, let's do increments of 1. Let's say 5 minutes, guys. I'm here. If you have questions, please ask me. Give me 1 second. I will bring some water, guys. Yeah, I'm back. 3 more minutes, guys. Okay, 1 more minute. Have you done one of them at least, guys?
Yeah.
Okay, so let me resume and let's continue. So let me check. This is okay. So let's create first the sequences. Okay, I will call them Q1 from 0 to 020, 015, 012. Okay, so let's do 0. Q1 equals 0 to 20. I want Q2 to be 0 to 15, I think, right? And Q3, 0 to 12. Okay, once you have, these are your x's, correct? Because Q is in the x-axis in economic terms. Q is my x. So basically I need to do A, I have A and B multiplied by Q, then I can create the demand functions 1, 2, and 3. Make sense to everyone? So I can do Q D1, the demand function 1 equals, what was my coefficient? It was 10 is my intercept minus 0.5 times Q1. Agree with me, guys?
Yes.
Okay, so this is the first one. The second one is going to be, what is it? What is this one here?
15 minus 1.
15, yeah, 15 minus 1. 15 minus 1 times Q2. And the last one, yes. The last one is what here?
30 minus 2.5.
30 minus 2.5. Here we go. Okay, so we have 3 demand functions, guys. And I will do more on graphicals later, but let's do a simple plot so you can have an idea what we have done. The plot command, guys. Okay, we're gonna do more about this later. But the plot command is always XY. Okay, and then we can add many other things here. So let's plot all of them. So let's do plot. So my X is going to be, for the first case, is going to be Q1. My Y is D1. I'm just plotting. You see the first line? This is the line created by Q1 and D1. Now, if I want to keep adding more, please pay attention here. If I want to keep adding to this same graph more lines, what I will do is I will do something that is called hold on. Okay, so hold on tells MATLAB the new graphs are going to be part of the existing graph. And then once we are done, we need to do the hold off. Okay, just remember that. So now I want to plot Q2 with D2. And what I will do is I will put this red. Okay, so the apostrophe red, apostrophe R, apostrophe means plot this in red color. So take a look to what happens. This is the second line. And let's plot the third one. Let's do this green, perhaps. And here you go with three different, and we're going to discuss this in detail later. When we do elasticities, when we do an M file that is a program, we're going to use this and we're going to compute elasticities, we're going to compute everything. But you see, this is the way in which you can create demand functions in a very simple way. Questions? Remember, once we have done the graphs, we simply do hold off. Just to tell MATLAB, okay, MATLAB, we create new figures. Questions, guys? Let me save. I think it was saved. Yeah. So now what we're going to be doing, questions, guys, up to here. No questions? Okay, so let's go and work with arrays now. Again, we have done this in the YouTube video, but I need to be sure you understand everything. So what is an array, guys? Is simply you have a vector, a matrix, and you put another matrix, and you can put as many matrices as you want. So these are faces again. These are rows, and these are columns. So how do you address a matrix, an array? Okay, let's call this array A. It's going to be rows, columns, and faces. So this is the way you're going to read the data. Okay, so let's do two panels, guys. The first panel, I will have here years. In this side here is going to be individuals. The first panel is going to be income. And the second panel is going to be savings. Okay, so what I want you to create, hopefully you have created this from the video, but let's recreate this one here. So, and we need to type this, guys. So this is going to be $100,000. This is individual one. Year one. I don't know how many years we have. 3 years. Yeah. Individual one, individual two. So I have here 72,500. And individual three, I have 41,000. Okay, so let me copy and you please create this matrix. 125, 82,500. So this is year 2, year 3, year 4, and year 5. And this is income. And this is my first phase. And the second phase, the same. I have individual 1, individual 2, individual 3, year 1. Please be creating this in MATLAB, okay? And this is going to be savings. Where do I have the savings here? Two 500. Okay, so create these matrices. Sorry, this is going to be an array. So how do you put this one here? So let's call the data this one here. Let's call it. Is going to be. We'll write this here. Let's call the name of the file of the matrix is going to be panel data. And in order to input everything, it's going to be all rows, all columns, first phase. And this one here, of course, is going to be panel data, all columns, all rows, all columns, second phase. So this is the way you're going to create this. And of course, here, what you do is you simply type this as a matrix, right? It's going to be 100,000 space 72,500 space $41,000 semicolon, and then you continue. Okay, and this one here is going to be 35,000 space 22,500 space 1,000 semicolon, and then you continue. Okay, so let me do the same. Stop this one here. Allow me to type stuff. Two minutes to type this very quickly, please, guys. Okay, so let me show you my screen. Guys, you need to do this with me because there is a lot of exercises that are going to come with this one here. So what I've done is I've introduced panel data, first phase, all the numbers that I told you. Any questions about how to fill the data? Later, of course, we're going to start importing for Excel, CSV, or whatever other data sets that we can have. But for now, just want to do simple exercises that show you how this works very quickly. So I have the first phase, income, the second phase, savings. Okay? So if you want to see the data, you simply take a look to this one here. So this is my income, and these are my savings. Okay? Do you have this? Because I will start asking you questions, guys. I need you to have these values.
Yes.
Yeah.
Okay, perfect. So now let's go back to this one here. And what I want is the following, guys, from you. Okay, so we have a lot of things to do. So what I want is to create a third phase that is going to be simply equal to the expenditures. Expenditures. So what is expenditure, guys? Is simply the income minus the savings. Okay, so create a third phase that is, and is going to represent the expenditures. The expenditures are defined the incomes minus the savings. So let's do the second one. Okay, guys. So 5 minutes for the first three, and then we continue moving quickly.
Real quick, for
Yes.
part two, A equals income. What's the second word
Oh, yeah.
there?
Matrix. Yes.
Okay, that's what I
Income
thought.
matrix. So basically, what I want is just create a matrix A that simply captures the first phase and make it
Okay,
independent. Okay.
great.
One minute, guys. Okay, where are you guys? One, two, or three?
I already went on.
Oh, perfect. Okay. Someone
Yeah, I
else?
went on as well.
Perfect.
Okay.
Okay, so let's do this very quickly. So third phase of oh yeah, I need to create a third phase to my matrix. Okay, so let me resume. Let's go to the matrix. Okay, so I want to create, basically I will copy this stuff. No, I don't need this stuff, but what this is going to be is a third phase, right? So I'm adding a phase, and this third phase is going to be equal to what? Expenditures, right? So the expenditures are equal to what? Where the income is located in 1, and the savings is located in the second phase, correct?
Yes.
Do you agree with me? So what I'm doing is simply creating a third phase that is made of the difference between the first phase, that is income, minus savings. Here we go. And here, well, I'm showing everything. This is my income, these are my savings, and this is what I'm spending. Got questions about this stuff?
Yeah, I have a question. Is there
Yes.
anything wrong with just assigning like the panel data, like income as being like income equals
Oh, yeah.
is that okay, or is that gonna,
No,
is that,
no, it doesn't matter. But the thing is that you need to create one by one, right?
yeah,
Yes,
okay,
that's okay.
okay,
That's okay.
cool,
Okay.
thanks.
Now, so this is the first one. So let's go to the second one. Well, I just want A is going to capture only a piece of the array. And then this is something that we always do. If we have a lot of information that we don't use, I just want to use A. And A is going to be equal to just the income. Okay? So basically, this is the way in which you can separate an array into matrices. Make sense to everyone? So let's go to questions on A and B. So B is income and savings of individual 2 in a matrix. Okay, so we need to create a matrix now, not an array, of individual 2. So let's call this B, and B is going to be a matrix, correct? So I use the brackets. And this bracket is going to have in the first column what? Income is income is phase 1, but I'm just interested on individual, which individual? 2. So individual 2, remember that the columns represent individuals. So what I'm telling MATLAB is, okay, B is going to be a panel data of, what is this one here? All the years, individual number 2, and income. Okay? And then we can put this together next to it. I just want from this guy also, not income, but savings. Make sense to you? Guys?
Yes.
Perfect. So let's do this. And here we go. So this now represents, this is a B, is individual number 2, income and savings. C, I want income divided by savings for all years for all individuals. Okay, so that's easy, right? So it's called C. C is going to be equal to, oh yeah, I have this one here. I have for all individuals, and I want this to be divided. So remember, it's going to be element by element division, correct?
Yeah.
Okay,
That's
because
what
remember, guys,
I did wrong.
matrix division is also different than element by element division. I will show you that once we do more linear algebra. So basically, this is going to be 2. So what I will do is I have every individual's income, I divide by its corresponding savings. Oh, I'm saying savings, or what is it? So I'm saying, savings over income, sorry. Should be the opposite. Savings is in 2 and income is in 1, correct? And this is something true, guys. We are working now with a co-author in terms of the impact of tariffs on on the prices of food and beverages. And of course, you can understand that the impact of an increase, a 5% increase on price of food and beverages, guys, they don't affect equally all citizens. Do you agree with that? Agree with me or not, guys?
Yes.
Yes, and why is that? Because what happens is that normally the people have different income. Okay, the lower income people, they are the ones that are going to be looking for promotions, discounts, etc. And these guys are normally the ones that are more affected by a price increase. So that's why inflation, guys, is terrible, and that's why the Fed controls inflation, works against inflation all the time, and of course in parallel to decrease unemployment. But why? Is because inflation affects most to the poor people. Got it? And so the same happens. Inflation, if you put a tariff, guys, this is a tax. A tax basically is inflation, okay? Creates inflation. So the same inflationary processes affect more the poor people than the non-poor people. And this is what happens. If you take a look to the savings of, I don't remember this data came from somewhere, but it came from somewhere. You can see the savings, guys. Take a look. This guy start making $40,000, $41,000, and saves $1,000, and then he starts going up. The savings also starts going up, but very, very, very mildly. Do you see? Because it's proportional. What you can save is proportional with the amount of money you can earn. Make sense? Now, if you start earning $100,000 and then you jump very quickly to $425,000 in 5 years, we have seen that. In Wall Street, for example, you can see that. Of course, you don't consume your ratio of expenses doesn't go as fast as your ratio of revenues, okay? And that's why what happens is at the end of the day, you are able to save more. And now you're not only able to save more, but you're able to invest in more financial instruments. For example, if you have more money, you have access to equity markets. Even though now equity markets, everyone has access to equity markets with Robinhood, for example. But the thing is that if you make 10%, guys, over 1 million, it's $100,000, you agree? And making 10% over $10,000 is only $1,000. So the magnitude of your investment impacts your magnitude on your absolute dollars that you're going to make. Got it? So these are things that we're going to be seeing this later, but the intuition goes in this way. So normally what happens is that high earners make more savings in time, and low earners also make more savings, but proportionally is much lower than the pairs on the higher earners. And in magnitude, in dollar-wise, also is much less. You can see this here. This guy is saving 8,500 by the end of the 5th year, and this guy is saving 354. Just numeric examples that we need to start analyzing later. Make sense? We have C. Okay, so let's do 3 more minutes for you to do D, E, F, and G. I pause this one here. 3 minutes to do D, E, F, and G, please. 1 minute, guys. One minute, guys. Okay. So let's do D. You tell me. Okay, let me start recording. So D is the income of individual last 3 years. Okay, guys, you tell me. We'll copy this one here and you tell me. I want the
So-
income of individual 3. Income is 1, right? Okay, so what I do here?
Yes. Is it panel data 1:3?
Okay, the last 3 years, wait a second. So last 3 years are the last ones, are these ones.
Oh, it's the last 3 years. So
Yeah,
it's 2:3 or just column 3.
3 column 5, I think, right?
Yeah.
Okay, now when you go 5 is the last one, we can use something that is called, I'm sorry, I need to do the small caps, end. 3 to end, also the MATLAB is going to understand that. Okay, 3 to the last of the rows. Okay, so this is the
And
last
then
3
3.
years.
Yeah.
Individual number 3, and we're talking about income. So this is 1, correct? Here you go.
Yes.
Perfect. So now let's go to E, savings of individual 1, only year 5. What is this one here? Oh, year 5. Individual 1, year 5. So I want the 425, correct? This is going to be the E. Okay, you tell me, guys. What do I write in every position?
5, 1, 2.
5, 1, 2.
Yeah.
Okay, 5 is the last year, last row. 1 is individual number 1, column represents individuals, and 2 savings. Make sense to you guys? Oops, what happened? My savings are 354,980. We can see that. Oh, it was savings, this one here.
Yes.
Perfect. So we are F, income of individual 1 as a percentage of income of individual 3. Okay. So this is going to be F. I will copy this one here. Okay, income of individual 1 for all years, right? So this is the income of individual 1. Agree with me?
Yes.
And then I need to do as a percentage of income of individual 3. So I need to do element by element division. Basically, of individual 3, the only thing that changes is this one here. Correct?
Yeah.
Perfect. Then we go. Easy. Wow, you can see. And this is something that is observed also in real life. The starting point is crucial, guys. You know, and this is something that I always tell the students is you need to look for a position, even as a junior position, but it's that the starting salary is good and significant. If you're finance and economics and IT, you need to focus your efforts on going to, well, the issue with the salaries, guys, is the other thing is that it's a lot of time. Do you agree? So if you want to make a lot of money, go to investment banking, but you are not going to have a life. So you're going to start working very early in the morning and finishing very late at night, even Saturdays and Sundays. So if you have a more relaxed life, you can balance. Perhaps you can go to corporation, or you can look for different positions. But the thing is that remember, effort and results are linked to salaries in general. Okay, so just we're going to do more exercises about salaries later in time. Okay, so let's do one more. And G, what we say is change order of individuals. So I want 3, 2, 1. Okay, we have done that before, right? Let's see. So this is G. G equals what? Okay, my panel data, what I need to do? What I'm changing, guys, the columns or the rows? What I'm changing? No, sorry, this is not Y, this is individuals. This is individual 3, individual 2, and individual 1. Okay, how do we do that? Guys, everything that we do connects, okay? So what we are changing? Columns or rows? Columns. Okay, so what I want is that the last column to be the first column, etc., etc., etc. So we have done that. So how do I do that?
We can use the flip left to right.
Okay. Oh, yeah, that's right. I can do this directly. I can do a flip left to right. The flip left to right of this one here. And that's it, right? That's simply it. Or, you know, if we want to use, let's call this G1. If I don't want to use the flip left to right, sorry, G11. I want to use the sequences. I also can do, and please remember that because we can do a size. You tell me what I'm doing, huh? Size of panel, blah, 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 comma 2. This is number of columns, minus 1 to 1. Remember, we have done something similar. So what it will do is we'll take size of panel data 2 is number of columns is 3. So it's going to be 3 minus 1, 2 minus 1, 1. Here we go. It's the same. Make sense, guys?
Yeah.
Okay, questions, guys? Questions? No questions? So we can move?
Yeah.
Okay, perfect. So let me save this one here and then we do another topic. File, save as. Just give me 1 second, please. So now let's go, and you're gonna do this, okay? And I will new. So let's start doing cash flows. In economics and finance, we use a lot this term that is called a cash flow. Okay, and indeed it's very powerful for, we're gonna use this for analyzing bonds, for analyzing IOUs, analyzing asset prices, etc. All right, so a cash flow is very simple, guys. It has 4 components. It has, I will draw one. Okay, so this is a cash flow. It has an outflow. This is an outflow. So there is money exiting your bank account or exiting your pocket. There is an inflow. There is money coming in the future for you. This is time. And we have another thing that is called an interest rate. Okay, so that is not present here. So now when you invest money first and then you receive money in the future, this is a cash flow, an investment cash flow. An investment cash flow. Now, if you receive first money, for example, when you buy a car or when you buy a house, and then you have multiple payments, okay? And then in time, you make a payment, this is called a financing cash flow. Make sense? Okay, so from here, what we can do is the following. We have something that is called a compounding interest rates. I will just focus on compounding interest rate. What is interesting with compounding interest rate, guys, is that interest create interests. So basically what this means is that if you save $100 now, in a year you have 110, for example, if the interest rate is 10. Then for the next year, what is the principal is going to be 110. You see? So the 100 plus your 10 is your new capital, and then this starts increasing. Make sense to you? Guys, make sense to you?
Yeah.
Okay.
Yeah.
So what is the meaning of that? So I will do just very quickly, and you tell me if you understand this part here. So I will do a cash flow and periods. Okay. So, and I will just focus on the first two. Imagine, guys, this is my C0. This is first period. This is 0 period, second period, and then you have end periods. And then what you're interested is in finding what is your CN, what is your future value. So take a look, guys. Assume that the interest per period is I. Okay, 2%, 3%, whatever, per period. So what is the interest that you're going to make in here? The interest is going to be your initial capital times the interest. So imagine that you have 100. So let's do an example. Imagine that you have 100. So your interest is going to be 100. And let's assume that this is 2% per period. So your interest is going to be 100 times 0.02. This is going to be equal to, your interest is going to be equal to 2. So how much money do you have at the end of the period? At the end of the period, guys, you have your C0 plus your interest. That is C0 times I. If I simplify this one here, this is C0, 1 plus I. Okay, so this is the new amount of money that you have for the future. In terms of numbers, this implies that I have 100 times 1.02. So indeed, I have 102. So this is the new amount of money that I have for period 2. Now, in period 2, what is my interest? My interest in period 2 is going to be the C0, 1 plus I, that is what I have at the beginning, times I. So how much money I will have at the end of period 2? I will have C0, 1 plus I, that is the money that I started with, plus my interest, C0, 1 plus I times I. If I simplify this one here, C0, 1 plus I, what I'm doing, sorry. No, sorry, this is okay. C0, 1 plus I, and then plus 1 plus I. So at the end of the day, how much money do I have at the end of the second period? C0 1 plus I squared. Okay, now if you do this exercise, guys, n times, your Cn is going to be equal to C0 1 plus I to the n. Do you agree with me? Just if you follow the logic.
Yeah.
Okay, so in economics and in finance, we don't call Cn and C0. Cn, that is a future value, we call it future value. The future value is going to be equal to C0, what the money that I invested at the very beginning is called present value, and 1 plus I to the n. Okay? And also in economics, we don't use normally this equation, but we use a variation of this equation that we call PV. PV is going to be equal to future value 1 plus I to the n. Okay, so this is normally the equation that we use in finance and economics. Is what we do indeed is we have two operations. So if we are in period 0, we are in period n. What we do is if we have money in the future and then we discount this money, if we bring this money to the present, this is called discounting. Now, if I move money from the present to the future, so if I go this way here, this is called compounding. Okay? And the formulas are basically this one here. Make sense?
Yeah.
Okay, so exercises for you. Let's do one example. And you do this using Excel. Example 1. Okay, I have a cash flow. Imagine that it's very simple. I do $500. Remember, when I do down, it's minus, okay? But in my graph, in my cash flow is only 500. And then I put my $500 for, let's say, 6 months. 2, 3, 4, 5, and 6. Okay? And what I'm interested is, what is the C6? If the interest per period equals 2%. So tell me, what is its value? So you use this value, this formula, right? Okay, so this is my first exercise. The second one, please start programming this one here. My second one. So now you make a deposit now at time 0, $500. Then in 3 months, you deposit a second amount of 250. It's 50. And then I want to know how much money you're going to have at the end of the 6th period. Again, if the interest rate per period is 2%.
And that's at year 3, you deposit the
Yes.
additional 250?
250, exactly.
Okay.
Okay. Just for simplicity, guys, what you can do is, of course, you can move this money directly to the future, this money to the future, just different periods, and then you sum them all. Okay. Just do this. It's much simpler at this point.
Sorry, can you
Yes.
repeat that?
Yes, what I mean is, remember, what you can do is you can imagine the 500, this example. What you did is you move this 500 directly to the future. Do you agree? What you can do is you can do one cash flow, one future value from 500 to the future, and then the other one, you move it here. You have a quantity here, you have a quantity here. You sum these two, and then you obtain your C6. Make sense?
Yes, thank you.
Pleasure. Okay, let's do these two, and then I will give you a very simple homework for next class. And pause this one here. Let's say 5 minutes, guys, for doing 1 and 2. 1 and 2 are applications simply of the formulas, right? 3 is a little more complex. You need to start. I will give you some insights and you can start working on that later.
Yeah.
2 minutes for everyone else so to be able to do exercise 1 and 2, please. One minute. One minute, guys.
Professor,
Yes.
for example 3,
Yes.
I'm kind of lost.
Oh yeah. Let's work on I will give you some insights and then you need to do this in MATLAB, okay? Let me resume.
Okay.
Let's do the first ones. It's very simple, it's straightforward. The first one So what we have in the first one is 500 and 2% 6 periods. Okay. So for this one here, let me define C0 as 500. Let me define I as 0.02. Do you agree? Then let's define N as 6. I have 6 periods. Oh, sorry. N equal 6. And then from here, I can find my C6 is going to be simply equal to C0 times 1 plus I to the power N. Do you agree, guys?
Yeah.
This is a piece of cake. Now, the second one, where is my second one? My second one, I have a C3, right? C3 is 250. So the only thing that changes here is that I have another cash flow of 250 in period 3. Make sense?
Yeah.
So what I will do is I will call this, oh, I didn't call this C. Okay, so I know why I call this C. My mouse is not working properly, so my keyboard. This is C6. Okay, so this is my C6. Now, what I want, this is this value, the $500. The $500 moved to the future are this one here. Do you agree? 560 something. This value here is 563. 563. Okay, so I need to find only this value here. So this value is going to be my C3, 1 plus 0.02 to the power of what, guys? What is the power? How many periods I need to move to the future? I have 1, I have 2, and I have 3. Do you agree?
Yes.
Okay, so basically this one here is going to be, I need to do this again. And then I have, let's call it C63. These are names only, guys. I'm terrible with names. So it's going to be basically my C3 times 1 plus 1 plus my I to the power 3. Agree? So this is 265. This number here is 265. And then to find your final cash flow, 6, simply you sum these two numbers. So your final, let's call this C6 final, is going to be equal to your C6 plus C63. Do you agree, guys? Guys, do you agree?
Yes.
Yeah.
Yes.
Okay. So we obtain 828.3832. You get this value?
Yes.
Okay, perfect. Okay, so now let me give you an explanation of this one here. Okay, exercise 3. Here's what you need to apply, guys. It's very straightforward, but you need to apply your rep math. You need to do, a bunch of things that we have done today in class. Okay, so what I suggest you is to do the following suggestion. Okay. So what I suggest to you guys, give me 1 second, please. Give me 1 second, please. Okay, guys. So, suggestion. What I suggest you to do, guys, is create a matrix. Okay? We can create a matrix. Because, okay, so let me explain you how this works. First of all, you're gonna have minus $1,000. You don't do anything. So what I need to do is I need to bring all these monies to the present. Okay, so that's the idea. Okay, the 1,000 I cannot do anything. The 1,000 is at time zero, so I don't do anything. How do I bring the 750? So I'm gonna be using this formula here, guys, the PV, because I'm moving from the future to the present. So this one here, the 750 is going to be divided by 1.02 to what power? How many times do I need to move the 750 to arrive to zero? 1. Do you agree? Guys, pay attention because this is crucial for what we're going to be doing, examples we're going to be doing in the future. Do you agree with me or not?
Yes.
Okay, perfect. So I move the 750 from period 1 to period 0. Perfect. Now I need to move the 1,200 from period 2 to period 1 to period 0. How many jumps I need to do? I need to go first to period 1 and then to period 0. Correct? How many jumps?
2.
2. Perfect. And the last one is going to be 500 divided by 1.02 power 3 because there are 3 jumps. Period 2, period 1, period 0. And this is your PV, okay? This is called net present value, but let's call this PV for now. So what components do you need? Well, I need, so that was, I was saying, you can see this one as a matrix, okay? So let's create a matrix. First of all, like this, with these numbers, 750, 1,200, and 500. What else do I need? Okay, these are my cash flows. What else do I need? I need my interest, right? And my interest for the first one is going to be 0, but for all these guys is going to be 0.02. 0.02, 0.02. So here you can use your RepMath because you are replicating these values. And then you need your vector of times because remember you have 1, 2, and 3. So you need a vector of 0, 1, 2, 3. So you can have a sequence here. Do you agree with me, guys? So you can create this with a sequence. You can create this with a RepMath. And well, you need to type this. Once you have created all these matrix, guys, so you have created your matrix, I don't know, call it whatever you want, then it's easy. What do you want to be doing? So assume that this is my matrix A. So all this is my matrix A. Got it? So how do I create this PV? My PV is going to be equal to what? Take a look. It's going to be A first row, all columns. Then what I need to do? I need to divide this by what? It's element by element division by what? Take a look. I need to divide this. So remember this one indeed is equal to 1 to the power of 0. That this is 1. So I need to divide this by what, guys? A, what row? Row 2. All columns. I can do another parenthesis. This one to the power of what? Of A, column, row 3, all columns. And another parenthesis. And this one here should be this formula. Yes or not? Guys, yes or not?
Yes.
Make sense? So basically, this is what you need to do for answering exercise number 3. And I will give you, please copy this one here because I want you to do this for next Thursday. And let's do another example, guys. Let's do example 4. That is going to be very simple, very similar to following with example 3. Okay, but now my interests are changing. So basically what it means is the following. Sorry, I need to delete this one here. So now my cash flow is going to look like this, okay? The $1,000 as before. the 750, the 1,200, and the 500. But now the interest here is going to be 2%. The interest here is going to be 3%, and the interest here is going to be 1%. So what I want from you is to find PV. So now what you need to change, remember that you use red math here. Well, in this case, you're not going to be using red math anymore. So instead of having, it's going to be 0, 0.2, 0.03, 0.01. And then you have the matrix and you do something similar, and then you should be able to do that. Oh. Wait a second. So here, there is something missing here. Because here, what you are doing, you're going to have a vector. Do you agree? Do you agree with me, guys? When you do this stuff, you're going to have a vector. In order to find your PV, what you need to do is you need to sum your PV aux. You sum, this is going to give you values like that. Value, 1, 2, 3, 4 values. Okay, number. Then you sum all these numbers, and then you obtain your present value. And that's your answer. Okay, think a little copy, and let me save this one here. So this is for next class, guys. Example 3 and example 4 are the first things we're going to do next class. Okay, here you're going to start mixing up rep math, sequencing, element by element division, element by element power, and creating your own formulas, applying the sum formula that simply sums the element of a vector or matrix, etc. Make sense?
Yeah.
Yes.
Okay, questions? No questions? Okay, guys, we stop here for today. On Thursday, we're going to start, no, sorry, not Thursday. Wednesday, we're going to start doing this stuff. Then we're going to move into more advanced financial examples. And then we do plottings. We're going to do subplots. We're going to do 3D plots. We're going to do a lot of things, and then we start moving quickly, okay? Please review this stuff, because this is the basics. Last class, this class, and the next class are the basics of something that's going to be much more complex. This is going to be very complex very quickly. So please review and understand this stuff, okay? Make sense to you?
Yes,
sounds
thank
good.
you.
Perfect.
Thank
Okay.
you.
So see you in a couple of days, guys. Take care.
See
Thank you.
you. Thank
Have a
you.
good night. Bye-bye.
Bye.
Bye.